Right, good afternoon. We are back in business. So, my name is Richard Tweed. I am a senior site reliability engineer with Thought Machine. They make core banking software and some payment systems. I've worked with Kubernetes since the battle days, about 1.6, 1.8, so approximately 5 or 6 years at this point. I've worked with EKS, GKE, whatever the Azure one's called, OpenShift on-prem. I've worked with them all. And I'm here to talk to you about Kubernetes dynamic permission. Now, before I get into it, just to help me level the talk, who here knows what Linux is? Hands, please. Linux. Okay, good. Containers? Okay, promising. Kubernetes? Brilliant. Dynamic emission control, or emission control as it's called. Brilliant. Right. Yes, it worked. Right. So, that's what I'm going to talk about. Glad you folks are here. And I'm going to be talking about using them, misusing them. Just to check, am I audible over the echo and all the stuff that I said? Brilliant. I do have a strong accent. I'm aware of this. If I'm unintelligible, if I'm starting complete gibberish, or you want to maybe clarify something, it's a cozy crowd. Just shout out, interrupt me, prompt for questions and things. I'm very happy to, especially when we're seeing a few people. So, here is what you're going to learn. These are the key takeaways. You're going to learn how you can use. Here you go. Just read it. Ta-da! But this is how you justify to your boss that you showed up today. Right. So, you know what Kubernetes is. So, I'm going to explain first the process an API request to Kubernetes goes through. Ignore this bit, I suck at Permeate.js. So, whenever you make any API request to Kubernetes, so say you want to create a pod, it will first go from you to the API server, then it will go through authentication, authorization, Kubernetes will check, is this a valid request? Like, does it match the schema, etc., etc. It will go through the entire points of this talk, which I'll talk about in a moment, and then after all that, the request will either be allowed or rejected. It will be audited, and then you'll get your response. So your kubectl command will exit 0 or whatever. Ta-da! This is unreadable, and that's fine. It's more to just give an idea of when things happen. So there's a difference between dynamic emission control and static emission control, which I'll talk about first. Static emission control is the things built into Kubernetes itself. This is, well, the API schemas are actually static emission control. Also things like you can schedule stuff onto the master nodes. All of that is like the built-in static emission control. This compares to dynamic, which is I bring my own logic, and that's what we're going to be talking about today. Bring your own logic stuff. So, what is dynamic emission control? So, there are two related things. I'll talk about the first one here, which is emission webhooks. For anyone who's not sure what a webhook is, Kubernetes will send you an HTTPS request, you do some stuff, return something to the control plane, and it does logic based on what you return. And just to repeat, the dynamic part is the fact that you bring your own logic, you bring your own plugin components, and can do some stuff. So, first, in this chain of dynamic emission control, are mutating webhooks. These take in requests and choose whether to change them or not, and whether to allow them or not. So, an example of using this is say you run the same workloads on multiple clusters, on multiple client vendors, and for whatever reason you can't template in the registry at build time, you could have a mutating webhook on the cluster that goes, this should be the GCP registry, this should be the AWS registry. Another example, say you have a multi-tenanted cluster, you're running a cluster, you have different teams, multiple repos, you can't protect build time. You could add annotations to the workloads based on the namespace. So like, this has building account A or building account C, or this is owned by team D, send that agreement, and you can do all of that through mutating the webhook. So, the thing that's called after that is called validating emission policies. These are in beta as of 1.28. And the whole point of these is that you don't need an HTTPS server anymore. You can just put in some logic. Kubernetes will use the common event language, which is the awful thing that they use for conditions on GCP IAM. So if it feels familiar, it's because it is. It's okay. It's this weird bit of language for doing admission-y stuff. So Boolean logic. I'll show an example in a little bit, but what you can do here is yes or no based on your own custom logic. But you can only do yes or no here. And this runs inside the control plane, so you don't bring anything else. So here's an example of one. So it's some YAML, because what Kubernetes thought would be complete without it. And what we're actually showing here, and this is the only piece of this that matters and isn't some damn boilerplate, is that if I'm creating or updating a deployment, then the replicas must be less than 5. So I'm saying you can have as many replicas as you want, but less than 5 because you're over budget, right? And again, the only pieces of this that matter are you say, what things do I care about? So in this case, I care about deployments and anyone who's changing them. And what object do I want to do? And you can put as many or as few Kubernetes API objects as you want here. You can even have star. Like, if you want something that happens anytime an API call comes in, it's better star. But that's going to make your really hard to write. So, here's a more realistic scenario. So, on the left, I have a policy, and again, the only piece that matters is at the bottom. What I'm saying is, in the production namespace, you have to use a hardened runtime class. Because your stuff is so spicy, it needs to be really well isolated, really well controlled. And on the right is an example of code that you can put in that namespace. So in the working case, you set your runtime class to be gvisor, so it's nice and secure, that would pass and be able to line in. And in the case that's uncommented, it will fail, and you will just get a refused back from Kubernetes. It will tell you, nope, you don't get to do this. Fun fact, this pod is created by a deployment, it's going to keep trying to make the pod. It's just not going to succeed, which is one of those caveats around this. So, last but not least are validating webhooks. So, in this case, you have to have your own HTTPS server. It has to be HTTPS. Again, Kubernetes will send you a request that matches your configuration, and you get to decide whether it passes or fails. It's allowed or it's not, and that's it. The main difference between the validating emission policies, which is what I was just talking about, and this is you have to bring your own workload to validate the logic, and this workload could make its own API calls. You could have it to do some other logic. As an example, you could have some sort of cost management system. Whenever somebody tries to spin up a workload, you go and check whether they have any quota left, whatever that means, and then if they do, they get to start it. Otherwise, not. Yeah.
So the response of this of some third party, let's say, is only yes or no, or you can change read it.
So I'll repeat it for the recording. So the question was, when you have a validating webhook and you're contacting third parties, does the response from the third parties have to be yes or no? The answer is it doesn't matter. The only thing that, this is your own custom code, it can do whatever nonsense you want. It can lock all the doors in your house if you wanted it to, if you wrote some bad code. The only thing that matters is that you send back to Kubernetes, yes or no. Whatever calls you make to get there, doesn't matter. So, in terms of ordering that these things are called, first come the mutating webhooks. These are all called, and you can think of it as all being called at once. If any of them mutate the object, it will get resent to all the other ones that then can decide whether they want to mutate it or not. And possibly including itself. So your stuff has to be idempotent, or else you keep getting called, you keep editing stuff, you keep getting called, you edit stuff. So this will happen and eventually, hopefully, finish. No more changes. If any of them rejected at all, that's it. It just gets straight up rejected. But if all the mutating webhooks allow it, then it goes on to the next stage, which is the validating policies, the new stuff. This is done by the code control plane, and in this case, they're all executed. If any of them fail, rejected, otherwise goes on to the next stage. And then it's validating webhooks, same thing. Send to everything, and then if it all passes, it goes back. At every stage, you can choose whether, and I'll talk about this. So, this is the JSON blob that Kubernetes will send to you, or equivalent. And that's ugly. So, we do get video. Excellent. So, I have printified the YAML. It might even choose to load on this Wi-Fi. If it doesn't, we'll move on. But the key takeaway from this is you get sent this object, which is an admission review object. It contains the original object and the metadata about what API call was made and who made it. I would point to this, but I can't actually get over there without reading the recording. But what you would have seen is it tells you what groups the API user is in, what the user was, things like this, and other metadata around it, plus the original object of the API call. So you've got some quite nice metadata there. Right, so now that we've seen what exists, distribution. Wi-Fi hates me. I was going to show the specific pieces, but essentially what you can choose is, for example, this group can only do these things, or if this group does something outside of business hours, fire an alert over to your scene, for example. You can do that. You can do that sort of advanced logic based on it. So, what are the limitations? At every single stage of these, you can choose whether it fails open or closed. So you can fail the request, but still have it happen, and it will show up in the on and off. So this is useful if you want to. You can use that as kind of like a dry run or night run, right? You can turn it on, but tell it Kubernetes to ignore what you return. And then you can see, is this going to cause me a noise issue? So that can be handy, but the other flip side of this is if you have them choose to fail closed, and your code is a bug, or your dependency, if you're calling off to something else, isn't working, your cluster is sealed, right? Like those API calls will all get blocked until you restore there are cases where this may be appropriate, but this is a real, like, watch out for this. You can really have a bad time. They also take time to process, which again is on the API path of everything that's coming in, so you can really slow things down. The minimum timeout you can tell Kubernetes when it's calling you is 1 second. 1 whole second is the minimum timeout for this stuff. I'm not very happy with this, but that's the choice that they've made. Mutating webhooks will be sent requests that are already mutated, or at least they can do. So, you need to make sure that whatever you're doing is idempotent. Like, really, that's the key thing. You have to be idempotent to requests. Also, none of these resources can act on themselves to stop you hard lock yourself out of the system. No mutating webhook can change a mutating webhook. No validating efficient webhook can act upon it, which again is there for safety and can sometimes be annoying if you wanted to add some custom logic. So, how can you use these? So, I'm going to start off with some proper uses for this stuff. So, you could use a validating webhook to check whether you have enough quota left. Say you're running a grid for your teams, like batch processes, they get, I don't know, 4,000 CPU hours a week or something. Kubernetes doesn't really have a concept of that, so you could build that in here, as an example. You can use a mutating webhook to do some security best practices. So, if your users in a multi-tenant cluster don't set a user ID to run as, you force them to be something else. So, yeah, they run as nobody or user 37,000 or something, just principle privilege. You could also choose to set naming conventions on this stuff. Again, it's just an example, but it may be necessary in some multi-tenanted situations. Like, it has to be department, team, workloads, or some accounting reason. Well, you can force that to happen here. So, fun new misuses. You could just build me a binary after some time for some chaos engineering. This is a thing you can do. Not should, to be clear, but you could do it. You could have a validating webhook that just sends secrets off to some server. You could listen to every mutation or creation that happens, and then use this to create an audit log. I can say the project review on rest, and that's literally how this works. If you just want mutations or creations, you're happy to leave aside your Googling. You don't have to pay certain cloud vendors or certain fees. You just do this. You could also register a validated webhook that sends a request to the coffee machine if somebody deploys a critical service after 6 months. I'm not saying you should, but you could. Alright, so key takeaways again. If you have an interest in this, here's some useful resources. The diagram that I showed, I'm currently trying to get into Kubernetes official documentation. Hopefully it'll be there in, say, a week or two, and you'll be able to see it there. That's the talk. Any questions? Yes?
Hi, it seems to me that this is quite similar to the Open Policy Agent. Do you have an experience with it, or how would you compare the two solutions?
So Open Policy Agent is one of these. It's just the language that they use is Open Policy. Sorry, I'll read it for the recording. They're asking, how does this differ from Open Policy Agent or Kubernetes? Open Policy Agent and Kubernetes are a mission controller, one of these dynamic mission controllers. probably validating rather than mutating, but I don't remember. And all they do is allow you to bring your own logic, and then it will execute it for you. So it's just a fancy HTTPS service. That's the only difference here. Yep.
Also, some security vendors, namely Finlay, using relation controllers to collect API data instead of audit logs. So I'm wondering if there is this kind of security with relation controller, will it change some of my application as well? Or does it eat all the stuff by itself?
Yes, of course. So the question was, there are various things that use this for security purposes. Can I also make sure my thing happens? Yes. So they all get called on all matching API calls in vaguely alphanumerical order. The only caveat I would say is that there is no guarantee your thing will be called first or last. So for these, that's one of the limitations of Kubernetes REST. I don't know, I wouldn't be able to know that the request I audited actually happened or not, because other webhooks could have rejected it after I saw it. It's a limitation, but again, it's something that you can use. So yeah.
It can interfere if I have multiple machine controllers.
Not interfere, by the way, they're designed. So if I go back here, the only way they could interfere with one another is if they both are mutated. So if one thing changes something and another one changes it back, and then you end up flip-flopping forever. But the validating webhooks, they all run, and it's only if any of them reject it. But if any of them are rejected, then the request is rejected. So if you want to have like 4 different ones that verify 4 different things, you can do that, and you'll get a guarantee that if any of them reject it, it will be rejected. Yeah. Any other questions? If anybody's daunted by this stuff and thinks it's really complicated, the original version of Kubernetes REST was 60 lines of code, and that ran in production for a while. These are all you need to do, which was why I'm really annoyed with this pitch didn't know. I'm going to try it again. Anyway, while I attempt to have this go, no. Okay, anyway, it's not loaded, but the response, the minimum viable response from a mutating or validating webhook is a JSON, which has the UID of the request and the equivalent of allow true or allow false. That's it. Like, it's not some crazy API. You genuinely just need to put in the UID and yes or no. So I wouldn't be daunted by these. You do not have to use solid client code for this. You genuinely can just have this tiny piece of JSON. Right, any further questions? Okay, we'll stop recording there. If anyone does think of anything, I'm going to be here all day. I'll still be in the bright green t-shirt, so just wander over and ask me stuff. Thank you very much.